Hi, and welcome to the 6th episode of our base builder tutorial series where we're using SpriteKit and SwiftUI to create a small base building like game. And it's been a while since we had the last episode, but today we're going to work on visualizing items. So where we left off last time is that entities are now visible. As you can see here in the screenshot, we can see the entity. We can see its position, we can see that it's working on building this room. And today we're going to add a visualization for the items that the entity uses, for instance, to build stuff. So it's really quite similar to visualizing tiles as well as entities. We'll create an item sprite manager. It again will cache sprites and sprite nodes. It will take care of cleanup of items as if they no longer exist in the world. We will add the sprite manager to the game scene and we'll add an items requirement to jobs in the demo world so we can see items being picked up. And finally, we'll take a look at the way entities decide how much to pick up when they pick up a certain item. But we'll get to that a bit later. First, let's start by at least visualizing items. So the first step will be to open Xcode. And we'll open a product. And we will create a new file. And we'll call it item sprite manager. And this one will require a SpriteKit, and it will be very similar to the other sprite managers. So we'll have a final class item sprite manager, and it will conform to the sprite manager protocol. It will have a cell size and a Z position. These are requirements from the protocol, and it will have 2 dictionaries to hold the items and the textures that represent them. So this will be our cache. This will map from a string to an SK texture, very similar to the tiles and the entities. And we will have an item sprite map, and this will take a look at which sprite is where, representing items on the screen. And this one will be a map from a location, a vector, to an SK sprite node. And this is quite similar to the way this was handled in the tile sprite manager. We need an initializer, and we will initialize with a cell size and Z position. And this will default to 0. So let's add our cell size and we'll set our Z position. And as every other sprite manager has a function called redraw world. Let's start by implementing this one, because this is really the meat of this class. So what we'll do is we'll loop over every item position and item stack in the world.items, and we will create a new function called setItemTexture. We'll create this in a bit. This will take an item and a location and a scene where to add it. And once this is done, we'll call the cleanup function, which we'll create in a minute. We'll start by creating the cleanup function because that's the easiest one. So we'll create a function called cleanup, and we'll create again a list of entries to remove. And we'll loop through all positions and nodes in our item sprite map. And what we'll then do is we'll see if there is still in the world at this location an item. So let's say we'll see if there's an item stored in the item dictionary. And then we will try and see if in the world in this location there's still an item. Now there's no quick way yet to get an item for a specific name and position in the world. So let's create a helper function for that. So we have one here in items management, get location with items. We're going to add an additional helper function called get item and named item name string add a position, and this might return an item stack. So we'll create an optional and return an optional item stack, and we'll see if there's an item stack at this location, and if not, we'll return nil. Then we'll see if there's an item stack here, it's the correct type. So we'll see if the item.name matches the item name that we were requesting. If not, then again we will return nil. Otherwise we will return an item stack for the item and the amount. So we now have a get item function we can use in our item sprite manager. So here in our world we can get an item named item.name at position, and if the amount here, and because it's an optional, we will default it, give it a default value of 0. If it is 0, then we'll add entries to remove this position. So to recap, what we're doing is we're looking through all the entries in our item sprite map. So that's all the sprites representing items on the screen. Then what we're getting out of those sprites is the actual item that's bind to them. We will do that in a bit. And then we check if that specific item still is available in the world at that position with an amount more than 0. Because if there are 0 or there aren't any there, then we want to remove the sprite. So then that's when we add them to entries to remove. So the second part is a bit easier. We look at the items to remove in the entries to remove. So we take our item sprite map. For location remove, we remove from parent, and we remove it from the dictionary as well. So that's our cleanup function defined. Now let's create our two functions that we have in all sprite managers. One that sets a sprite on the screen and one that caches textures. So we'll first create and set an item texture, and this will take an item, add a position in a scene. So we'll first get a texture, and this will use the get texture name function that we need to create in a bit. And then we'll say if there's already a sprite available, then we can reuse that by setting the texture to the correct value. If not, then we need to create a new SK sprite node with a texture have size, and this will be a CG size with the width and the height of both cell size. We need to have a position. We'll set it to a CG point where the X value is the cell size times. And this requires a cast to CG float of the position.x, as well as a Y value, that's the cell size, times the position.y. Then we need a Z position that was passed into the tile sprite manager, and then we will bind the item and item position to the sprite as well. So we can give it the sprite node some extra information, so we can set an item position to the position, and we can set an item to our item, and then we can set add a child, the node to the scene, and add it to the item sprite map. Really quite similar to the other sprite managers. And then we need to add one additional function that caches tiles textures, not tile textures, caches item textures. So this will be a private function, get texture named. So take a texture name, string, and an SK texture, and if let the texture is the item texture map, so if it's already in the cache, then we can just return the one we already have. Otherwise, we will create a new texture using an image named, and this will be our texture name. Then we will add this one to the cache, so we will use the texture name as a key and set its value to the texture, and then return the texture. So now this function exists as well, and I think all the required functions exist. Note that here as a sprite we are using the item's name, meaning that the item's name would always have to be the one that what is also called in the in your sprites catalog. I think it would be wise to do something a bit like the entity, where we have a specific value for the sprite, and to do that for the item as well. So let's create some a property here called sprite, and we need an initializer that's similar to the entity one. So we will set a name, and we will set the sprite to the sprite value passed in. But if nil was passed in, or it was kept empty, and then we have this as a default value, then we'll just use the name. And now in the item sprite manager, instead of using the name, we can use the specific sprite that we want to use. So this should be enough for the item sprite manager. Let's see if we can add this into our world. So let's go to our game scene, and here we create an additional sprite manager. We will put it between the tiles and the entities, so the tiles on the bottom layer. Then we will have the items, and then the entities. So this will be an item sprite manager with the cell size as defined and a Z position of 0.25, so it will be between the tiles and the entities. And then we need to make sure that we use this one in the redraw function as well. So we'll have item sprite manager.redraw. We will redraw the world in the scene that was passed in. And this should be enough to show some items. So let's make sure we also have some items to show in the world. Let's go to our demo world, and we have our entities here. Let's add a wooden block item. We will call it wooden blocks. We can use the same sprite name as this item name, because I think there should be one called wooden blocks here. So we will see these. We will add these into our world. So we'll have our new world dot items. I don't know. To the right, we'll create an item stack with wooden blocks. And let's say we will have 100. This should be enough to at least show the item. So let's see if this works. And here you can see our items. Notice that the entity is not picking up any items when building this room. So to show that that also works, let's add items as a requirement to these jobs. So we have our make room jobs here, and let's assume that to create a wall we need wooden blocks. So we have a wall here, we have our requirements here, we have a position requirement. Let's add an items requirement, and this requires an item stack, and this will require wooden blocks. Note that this is now stringly typed. We will improve this going forward in another episode, and let's say we need 2. So let's see if this changes the behavior of our workers a bit. Well, look, they're picking up blocks, creating a wall, picking up a block, creating a wall, picking up the blocks, etc. Notice that this isn't going very fast, and also I guess it's not really smart to just pick up the ones you need for the single job if you need to make many more. So I think it would make a lot more sense if the worker would pick up a stack of items instead of one or just the number that you specifically need for a single job. So what I want to do is I want to add a preferred stack, pickup stack size to items, so we can tell a worker how many should be picked up if possible. So let's see, so we have our item. Let's add a preferred pickup stack size. This will be an integer, and we can pass this one in here as well. And we will default it to 10. So if we don't specify anything in particular, this is the value we will be using. Then let's make sure that our entity actually tries and use this preferred pickup stack size. So we have our entity, and our entity determines how many to pick up. Let's see where exactly. We have our items to transfer here, and we're going to make this a bit more complex. So we're now taking the minimum of the of what is available or what is required. Let's keep the minimum for the available, so we never try and take more than exists, but in between the amount we need for the job, we will take the maximum and the item dot preferred stack size. So if the preferred pickup stack size is bigger than what is needed for the job, we will pick up the preferred pickup stack size. If for some reason the job requires more than the preferred pickup stack size, then that takes priority. And that should be enough to make sure that the worker now picks up batches of 10 instead of just 2 as needed for the job. So let's see if that actually works. So we're picking up, we're building, we're building, we're building, we're building, we're building, we need some more, we build, etc. So this seems to be working. Now, because we changed the logic in this function, basically we did more than just visualize, we also changed the model here. Let's see if that breaks any of our tests. So let's simply run all our tests and see whether they still pass. Unfortunately, they do. So that's all we need to do for today when it comes to visualizing items. Next time, we're going to integrate SwiftUI with SpriteKit and really start working on a user interface. This will take definitely a couple of episodes to get everything in, because this I've probably in this project this might even be most of the work. But as you will see, it's really cool using SwiftUI together with SpriteKit, and we can do some really cool things there. So thanks for watching. Have a good day.